And how many of those that you got? All right.
So, do I just explain how?
Yep. So you can put your sheet here. We'll make sure it's zoomed in correctly. Super huge. There you go. All right, so ladies and gentlemen, if you will look at your number 14.
I did all 3 for 21.
All right, Truth, you ready? 14?
So basically, I figured out that 65 had like that 13 and 5 both went into negative 65, and I also realized that 13 minus 5 was 8. So I did m plus 13 and m minus 5 because 13 minus 5 is 8, but 13 times negative 5 was 65, so it was factorable. So yeah.
Any questions for Truth?
Nope.
So 65 isn't one of the values that you see often, but it does factor. You might have had to plug it in your calculator. Nice job, Truth. That wasn't horrible. Yeah. Woo!
I just went to
You wait, you're just waiting.
I was
to use
waiting
this one.
So she can tell us.
All right, so how many not factorable problems did you find last night? 2, I see 2. Any more than 2?
No.
Sam, how many problems did you get to not factor?
0.
Yikes, 0.
Ethan.
How? How'd that go?
Well, maybe more. I don't know.
Did you look at it?
I was just going really fast. I might have not done the ones I did.
Going really fast.
Well, I did 24 hours ago. I don't remember. I did it like. I don't know.
All right, Sam, can you look at your number 7 and tell me what you have for number 7?
It's not factorable.
Oh, you have not factorable?
Huh?
Huh?
No, I'm lying. I did that one wrong.
All right, ladies and gentlemen, up here, please. So if you look at number 7 said p squared plus 2p plus 4. So 7 is not
Oh,
factorable.
dang it. It's not.
But why is it not factorable, Sam?
Because the 4 has to be negative.
What? Very false.
Wait,
Sam, what multiplies together to be 4?
2 and 2.
2 and 2, or
1
4, 1 and 4, 4 and 1. Will they ever combine to be a 2 in the middle?
Oh, no.
No. Because if you add 2 and 2 together, you get 4. If you subtract them both, you get negative 4. That's not going to be a 2. And if you use the 4 and the 1, well, you either have to add them both or subtract them both to keep the top number a positive 4. So number 7 is not factorable. So don't get tricked there and say it's p plus 2 and p plus 2 just because you see that positive 4 in the back. So that one is a not factorable one. And the other one, which other one was not factorable? David? Number 12. So number 12 says c squared minus 9c minus 18.
Oh, yeah, I couldn't get this.
So again, if you think of the numbers that multiply to be negative 18. So 1 and 18, 2 and 9, 3 and 6, which really looks like it should work because you got a negative 9 there. But I can't make both of them negative because that does not multiply together to be negative 18. And that's the only way you'd get a negative 9 if both of those were negative. So when you're working through the problems, there are going to be problems that are on there to like force you to almost be tricked. Some people aren't, which is awesome. But just make sure that you're looking to see, is it making the middle number, but it has to keep that top number happy as well. So 7 and 12 were the ones that were not factorable. Sam?
You ever have a decimal for these?
Sure, you could factor with decimals. Are you going to see them? Not very often, but yes, you could factor with decimals.
Okay.
Other questions? Are there other questions on the homework Just those two were not factorable. All the others should have worked for you.
They were.
All right, so today we are going to continue to look at factoring, but we're going to start solving the problem instead of just factoring, so it's going to become an equation. I also want to show you how to use the calculator to check your work. So if you want to take your calculator out, just so that you know how to use it. Your calculator's out of batteries. Sounds like a problem for mom and dad.
Or
Or for Ethan.
I borrowed from you.
Well, if I said no to him,
Oh.
well, yeah, but where's your calculator?
It's us.
Currently at your house.
and then I'm always
There is a Texas Instrument graphing calculator app that you can put on your phone.
How come
Why
I
haven't I
have
get apps online?
Wait, can I use that right now?
It is free.
Oh.
Wait, can I use that right now?
I don't know how it works. I haven't looked at it yet because I don't have it on mine. But Mr. Rebar told me that there is.
I have one. Can I use it? I have a question. How come the Texas industry has like a monopoly over the calculator industry?
Well, I mean, it's just like iPhone has a monopoly over.
But there's Samsung and there's Android.
Yeah, but there's Casio.
No, does anyone here have a Casio calculator?
I've never heard of a cast.
No, but somebody in one of my other classes has a graphing fancy Casio calculator.
It's not free, it's $4. Oh, okay.
That's still not bad.
Oh, is it $4?
Yeah.
I was told that it was free.
I mean, there's some that are free, but they're not like.
Not the.
They're not like premium.
Yeah.
All right.
That's
I might have to
There's one for $6.
talk to Mr. Rebar, the source who told me that. All right, so in your notes, if you can look at section 4.3, if you don't have a calculator today, it's all right. You just-
It's all good. We're solving this now.
Oh, I'm in a good mood today. This is only Thursday.
I'm sad tomorrow. We'll aim at the same time.
Here you go, grades.
Playoffs are like. And last year's playoffs were better.
All right, so today we're going to solve equations by factoring. And there are two terms up here that we're going to look at. One is a root of an equation, the other is a zero of a function. So these terms, you're really finding the same information, but the way your answer would be written would be slightly different. So a root of a function, or an equation, I'm sorry, happens when you are solving an equation in the form ax squared plus bx plus c equals 0. So a root of an equation is when the equation is equal to 0. A root is the same thing as the solution to the equation. So when you see the word root, don't get worried, I have no clue what a root is. A root is really just saying solve the equation, find the solution to it. Your solution is going to be an x equals form, so like x equals a for any number. X equals 5, x equals 2. You're going to have two solutions. So one would be x equals a, maybe the other one would be x equals b. But when you're solving, your answer is a solution. It's in the form x equals, because it's an equation. When you're solving it, it must be equal to 0 in order to solve it. And that was the definition of the equation we talked about yesterday. Why are there two answers? Because when you factor it, how many parentheses do you get when you factor it? So 2. So when you're factoring it, you get 2 parentheses. Each one of those parentheses represents a solution. Same. Sure. The second word underneath is the word 0. A 0 of a function, if we're talking about quadratic functions, it would be f of x equals ax squared plus bx plus c. So, I mean, essentially, they're pretty much the same. It's just one is an equation because it's equal to 0. The other one's a function because it does f of x or y equals. When you're finding a 0, you're finding an x-intercept. So a 0 means you're finding an x-intercept to the function, and an x-intercept is written in the form a comma 0, or maybe it would be b comma 0. It's called a 0 of a function because the y value is 0. Essentially, you're making the value of the function 0 so that you can find the x-intercepts of the graph. So a root is an answer, a solution. A 0 is the x-intercept or a point on the graph. You're really finding the same thing, you're just writing the answers differently. So if I'm finding a root, I'm writing it in x equals form. If I'm finding a 0, you're writing it as a point, because it's an x-intercept or a point on the graph. So it's more of the notation that differs, not really the process as to how you get it. Questions? So in order for us to be able to find roots and zeros, there's a little property that exists, and it's called the zero product property. So just like last year in geometry, you had a lot of theorems and postulates in order for you to solve different things in triangles or circles. It's the same thing here with algebra. We have to have some properties in order for us to be able to do different things with the graph. So the zero product property says if the product means to multiply, of two expressions is 0. So if I have an expression of x plus a, how about x minus a? And I have an expression of x minus b. If that is equal to 0, then one or both of the expressions must equal 0. Because when you're multiplying, the only way to get 0 by multiplication is to have 5 times 0, or 8 times 0, or negative 10 times 0, or 0 times 0. But when you're multiplying, one of these expressions must be 0 in order to get it to equal 0. I can't take negative 10 times negative 2 and ever equal 0. So with multiplying, one value must be 0 in order to get a product of 0 or a solution of 0. So that's what the zero product property says. So in algebra terms, if I have two expressions, a and b, a times b is equal to 0, then my first expression could be 0, or my second expression could be 0. Now why is this helpful? Because if I want to solve for x when you're factoring, there are two parentheses or two expressions when you factor. Because we have two parentheses or two factors to get our value. So if this was a factored problem, I have x plus 5 and x plus 2. If that's equal to 0, then what this is saying is that you can separate them and look at them as each individual pieces. So I can solve for x plus 5, or I can solve for x plus 2 to get those solutions. So if I solve for x plus 5, Sarah, x would be equal to negative 5. Or if I solve for x plus 2 and put it equal to 0, Sarah, x would be equal to negative 2. So the zero product property allows us to pull the parentheses apart from each other and solve for each individual x. You're going to have two solutions because there's two parentheses, there's two factors, two numbers that multiply together to give our solution.
Wait, I don't get that.
What part?
How come we have two solutions for x?
How many x's are in your problem?
2.
So each x has to be a different value to make this become 0. Yeah, the parabola has those two sides to it. It's going to cross through the x-axis on both sides. They're going to be different.
Oh, that's why you have two different x-intercepts.
Yes. Yep, exactly. So the parabola has a left x-intercept and a right x-intercept. That's what those represent. So if you look underneath, this first problem wants us to find the roots of the equation. So x squared minus 2x minus 15 equals 0. If you're finding a root, you're really just finding a solution. How would you find a solution to this equation? Factor it. Yeah, so we're looking at negative 15. Kate, what numbers multiply to be negative 15?
3 and 5, 15 and 1.
3 and 5. Let's go with 3 and 5. How would they make a negative 2?
You had negative 5 and positive 3.
Right, so a negative 5 and a positive 3. 3 minus 5 equals negative 2. So if you plug them into your parentheses to factor it, so positive 3 and negative 5. The zero product property says those two values as a product must be equal to 0, one of them or both of them. So you can separate them and find out the values that make it 0. So Kate, the two values that make this equal to 0 would be -3 and +5. So there's multiple reasons why there's two answers. Virginia was saying there's two answers because this is really a parabola. And those two solutions represent where the parabola will cross the x-intercept. There's also two answers because if I plug this back in for x, I would have 5 squared, which is 25, minus 2 times 5, so minus 10, now I'm down to 15. Minus 15 equals 0. There's two numbers for x that would satisfy this equation to make it equal to 0. We could do the same thing with the 3. So if I square 3, you get 9, and then you're subtracting 6, and then you are subtracting the 15, or adding 6 and then subtracting the 15. So there are two solutions for x that satisfy the equation.
So the solutions are just the inverse of, or the opposite.
The opposite
what
of
you plug in.
what's in your factor, exactly, yes. So the solutions are the opposites of what you're in the factor form. Because the only way I can get this to be 0 is by using the opposite. So if I have something plus 3, -3 plus 3 is the only way I can get 0. The opposite of 3 is how I would get 0. Other questions? So the second problem, again, pretty straightforward. It just changes the word. So it says find the zeros of the quadratic function. Find the zeros of the quadratic function by writing it in intercept form. Intercept form is that x minus p, x minus q form. Intercept form is the same thing as factoring. So all these terms mean the same thing. We're just using different words to represent what we're trying to find. So if I were to put this in intercept form, Mason, how would we factor x squared plus 5x minus 6?
Would you find the common in 3 and 2?
So 3 and 2, what else makes 6, Mason, besides 3 and 2?
1 and 6.
1 and 6. So both of these give us 6. Our goal is to find a positive 5. Paige?
I got -1 and +6.
So she said -1 and positive 6. Paige, why can't we use a plus 3 and a plus 2? Because that makes 5.
Because you wouldn't get -6.
Right, we need to make sure that the top number, if we multiply them together, that we can get that top number. So positive 3, positive 2 make positive 5, but it doesn't make positive 6 when we multiply them together. -1 times 6 does make -6, so that works for us. So we have intercept form of x minus 1 and x plus 6. So Paige, the intercepts would be
+1, 0, and then -6, 0.
good. So that means the graph passes through the point 1, 0 and -6, 0. Those are the intercepts. So there's a little picture here, but I want to show you on the calculator how you can find those values using the capabilities of the calculator. Make sure these solutions are in intercept form. They should look like a point. So if you're finding a 0, make sure your answers look like an intercept or a point on the graph. If I'm getting a solution, then it should be an x equals form. Just make sure you're writing your answers in the correct form. So if you could take out your calculator, because I want to show you how to put this on the calculator. So if you go to the y equals of the calculator, plug in that equation, x squared plus 5x minus 6. So plug in the original equation. So our goal is to see if we can come up with this graph. So go to y equals, plug it in, hit the graph button, we get a parabola. It's okay that we don't see the vertex because we're not worried about a minimum value, we're worried about the intercepts. And yes, for this problem, you can count and see 1, 2, 3, 4, 5, 6. So I've got a -6 and it looks like I have a +1. But we will run into problems where you have a fraction for an intercept or a decimal value for the intercept. And I want to make sure that you can use the technology to help you get that value. So in your calculator, if you use that second trace button, we use the second trace to find the max and the min. We will also use the second trace to find the intersect. So we've done numbers 3, 4, and 5. But if I'm finding the 0, number 2 will help us find the 0 of the function. So if you hit number 2, you have this little blinking guy. It doesn't matter which intercept you find first and which intercept you find second. I'm just taking mine to the left. Has to go down and then come back up. Alright, so there's my little blinking guy. There are always two numbers that you need to trap the intercept in between. And that's what the left bound and the right bound mean. So the left bound means you need to be on the left side of the intercept. So if my intercept is on -6, I need to be past -6. So right now my little blinking cursor is on the left side of -6. And then hit
lower limit.
enter. Say it again, Sam.
Mine keeps saying lower limit.
Mine says error bound.
Oh, there we go. I 300.
So the right bound means that you need to be on the right side. So here's my x-intercept. I need to arrow it right so that it's on the right side of the x-intercept. If you don't get to the left or the right, then it is going to say error because you didn't get on the left side of the value or the right side of the value. You never do anything when the calculator says guess. And then it should give you the exact intercept at -60, which we found algebraically. See if you can try the right side. Or try the other one.
Yeah. I can help you out too. Okay.
Yes.
So that's scientific notation. It's 6 zeros and 8 times 10 to the negative. It's super tiny. For some reason, sometimes it'll do it. Because you're not running further. You're not done yet. Enter.
The right of the I'm not sure that's why you're second.
Yeah.
So when you're doing that left and right down, or so again, if you didn't get the other intercept, please try and get the intercept. Anybody else have questions? Oh, we're finding no. So we're finding the 0. Number 2. That's So underneath here, make sure that you're reminding yourself that you're doing number 2. So we did second trace. And number 2 is the 0 function. So the calculator, like the tricky part of the calculator, you just need to make sure that your cursor is far enough to the left and the right when you're doing the left bound, right bound. If it gives you an error, that just means that you didn't go far enough left or far enough right. Some people are getting an E with like a -12. That's scientific notation. So that's just saying it's 1 times 10 to the -12, which is really equivalent to 0. It's a teeny, teeny, tiny little number. And the calculator does it every once in a while. Sometimes it'll give you 0, sometimes it gives you this crazy number. But it still is the value of 0. Stan.
How do people do this before calculators?
Oh, you just factor it.
You use the graphic calculator.
Well, you get like an abacus that's like the graphing abacus.
You don't need, like Sam, we don't need the calculator to do this. Even, it's just a checking.
Okay.
Like, when we solved it graphically or by, like algebraically, we don't need a calculator. Just to check it right. All right, so if you flip the page, please. Just not everybody has their calculator. Alright, so this last word problem here would be the interesting problem from the section. So, a town has a nature preserve with a rectangular field that measures 6 meters by 400 meters. The town wants to double the area of the field by adding land as shown. Find the new dimensions of the field. Now, one thing to note is that this is not obviously drawn to scale because it looks like the x on the length is different from the x on the width. But if they're the same x, they have to be the same distance. So we have this original field right here is 400 by 600. Our goal is to expand it. We want to make it bigger by adding extra land or space to the length and extra space to the width. So see if you can think about how to set up this problem, knowing that we are factoring and we're working with things that have x squared. It's all quadratic. So that means your answer has to have an x squared in it in order to find the solution. So try and set up something. So think like, what do you have? What do you know? Where can you use that to solve the problem? And we're talking about area. So what do you know about area? How do you find area? What if our brain gets emotions because we're using too much technology in the future? Yeah. So you just have to like hand them all in?
Yeah, I do that every day. Put them on a bin.
Because it makes your brain mush? Neat, why don't you make it very
Well, she said like, what happened yesterday was bad. I need to get a title.
Alright, so I see a couple of people trying to do some things. So, in this case, area is equal to length times width. What is the area that we're looking at? Paige?
X plus 600, well, parentheses, X plus 600, and then another set of parentheses, X plus 400.
So, if we want to find our new area, we have to take that x, add 600 to it. That would be our new length. And x plus 400 is our new width. And Paige, I think you probably foiled that. What did you get when you foiled it?
X squared plus 1,000 plus 240,000.
Okay, so 240,000. Make sure you're adding the correct number of zeros. There are 4 zeros in 600 and 400. When you multiply, there should be 4 zeros in your answer as well. So use the zeros to your benefit. You're really just taking 6 times 4 and adding the extra 4 zeros. So if you're solving this, we need it to be equal to something. Because our goal is to figure out the new dimensions. And right now, we can't find the new dimensions. I mean, sure, we could find the minimum value. That would be the vertex, but that's not our dimension because that's not solving for the x value. Okay? So you said multiply 600 and 400 because it's area, so the area is 600 and 400. But what do we want to do with that area, Ka? Yeah, if we want to double the area That means we need to create a new area by taking whatever the current area is and multiplying it by 2. Because we want to increase the size. I don't want to keep it the same. We need to make it larger. So doubling the area means take your current area, multiply it by 2. So if we double that area, what is 2 times 400 times 600? Good. So she said 480,000. All right, so the goal is to find x. X would be that new amount in meters that we're adding to the length and we're adding to the width. How would I use this equation to find that x value? Virginia?
I made it equal to 0 by 0 equals x squared plus 1000 x minus 240,000.
Yeah, so if you're solving a quadratic equation, it must equal 0 in order to solve it. You can't keep it equal to 480,000. You can't solve when it's equal to anything but 0. So you're going to have to take that 480,000 to the other side, subtract it, and then you end up getting a negative 240,000. Now, I want to show you how to factor this without using the calculator. I know this is a huge number, there were a lot of zeros. However, if you take away all the zeros and focus on the negative 24, and take away the 2 zeros and just focus on the 10. So we're looking just at the numbers 10 and negative 24. We'll add the zeros in at the end. So take the zeros out of the problem, pretend they're not there. What two numbers multiply together to be 24? Sarah?
So that would be negative 200.
Just give me just the number.
2 and 12.
2 and 12. And Ethan, you said, you were going to say? 6 and 4. So those are the numbers that would multiply together to be 24. We need them to add to be 1,000, but right now I just wanted you to think, how can we add to be 10? So how would these numbers currently add to be 10, Sam?
12 plus negative
So positive 12 and negative 2. Can we use the 6 and the 4, Sam?
2. No, because no combination would give us a negative 20.
Right. I mean, if they both add to be 10, it would be 6 plus 4. But again, that's not making the top number a negative 24. So we're looking at these two numbers. So in our parentheses, we have an x and a minus 2, and an x and a plus 12. If I have 4 zeros in 240,000, you need to make sure you're plugging those zeros back into your problem. So it becomes 200 and 1,200. So you can factor large values that have a whole bunch of zeros just by taking the zeros out and thinking of as 24 and 10, and then adding them back into your answer. So x would be 200, and x is also negative 1,200. So I get 2 x's, but there's only one of them that's the actual solution. Grace, what would you think? Which one is the actual solution?
Negative.
Yeah. So if we're talking about land, area, space, you can't have a negative amount of land. It doesn't exist. So even though I'm getting 2 answers, the negative 12,000 isn't part of the answer because it's negative. So Grace, the final question wanted us to determine the new dimensions of the field. How would we use that number to get the new dimensions of the field? Yeah, so if you plug it in for x, the new dimensions of the field would be 200 plus 400, so 600 meters by 800 meters. Questions? So we took what we wanted the new area to be, and it said we needed to double that area, so you needed to take the current area and multiply it by 2. So there is a word problem or two in your homework tonight, of course. to make the homework a little more interesting than last night's homework. And I have 59 and 65. And if you are in the band, I'll give you your worksheet in a minute. But 59, if you're not in the band, you'll be here tomorrow. Who would like to try 59 or 65? Isabella, which one did you want? 59? How about somebody to do 65? Nick, you'll be here tomorrow? Oh, you're in the band. He's like, thank goodness. Julia, you'll be here tomorrow? Yeah, thank you. 65.